Welcome to What's Best Forum's Masters and Makers interview series. I'm Ron Resnick. If you enjoyed this interview, please kindly click like and subscribe to my What's Best Forum YouTube channel. Today we are meeting Nicolae Jitariu, founder and designer at Rockna Audio in Romania. Nicolae, nice to meet you.
Nice to meet you, Ron. Thank you for inviting me here.
How many people do you have working with you at Rockna?
We are about 15 people working now. We started with 2 and now we are 15.
And what are most of those people doing?
Part of them, including me, we are doing design, and part of them, they are doing production because we want to do as much as possible in-house.
Do you work with any outside consultants, or all of the engineering and assembly is done in-house by your team?
We are designing everything in-house. We are not using any third parties to be involved in our design, except there are some parts of software related to control apps, user interface, where we have partnered with a local software company. It's Assist Software. It's a big software house. They are helping us in this direction, which is not quite directly involved into audio processing. It's just interface.
What is the design and engineering process at Rockna? Let's say you have an idea for a new improvement on the analog output stage. Who writes the schematics there for the designs?
We have a couple of engineers, which they are very skilled into this area. Actually, we started over 25 years ago producing amplifiers. So we know a bit about analog design. We switched to digital after a few years after the company was born.
Who physically assembles the DACs?
It's the production team, which is 6 people, and they take care of everything regarding production and testing.
How did you get involved in designing and producing DACs?
For me, electronics is more of a hobby. My formal education is in economics. I took this hobby to a good level, so to say. Working with my team of engineers, I think we are doing a decent job. How we ended up making DACs, we are not limited to DACs. We have as well servers, and in the beginning we had pre and amplifiers, power amplifiers. Probably at some time we will offer again something into the amplification area.
What is your sonic philosophy? What are you trying to achieve audio-wise when you place a DAC into a customer's system?
The pleasure of the brain. I'm not looking for a particular trait. It just needs to sound right. And this is difficult to explain. I don't want to use audiophile terms, so it just have to sound right. You need to feel that you don't want to stop. You don't want to press stop.
When you're testing and auditioning your own designs, how do you decide whether something sounds right?
We have some experience now, and when evaluating something new, it has to be at least as good or better than what we have done before.
Why do you prefer an R2R DAC rather than a sigma delta conversion DAC?
We have designed both R2R and discrete sigma delta DACs with our sister company, which is called AudioByte. And there we have as well designed using delta sigma technology. It's not about that I prefer one over another. I think the implementation is the key, not the general concept of R2R or delta sigma. Of course, R2R have some tendency to sound pleasant with, let's say, better texture, but also delta sigma done right can sound very, 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 very good. But to do delta sigma right is a difficult task.
And so is it that the R2R sounds more right to you, or why, given those pros and cons for the two technologies, you nonetheless decided to go with R2R.
I think R2R is just one piece of the puzzle. It's very important what we call the digital front end. You feed the DAC with some data, audio data, and you feed the DAC section with some clocks, of course, the power supplies. So everything must be right. You just cannot put R2R ladder and say, yeah, we have a excellent DAC because it's just R2R. The quality of the digital filters matter. Let's say the R2R is a little bit more forgiving than the Delta Sigma when it comes to the quality of the filters. But still, if you want top performance, you need to have very, very good digital filters. And this is one of the key points that we designed in time. We have our own system of making digital filters. Also, the quality of the clock and how do you do the whole processing regarding the clock receiving and what clock actually is used for conversion. It is extremely, extremely important.
Why do you prefer a phase-locked loop-based clocking system rather than an asynchronous sample rate conversion clocking system?
Asynchronous sample rate converter, it's a nice solution, but again, it needs to be extremely, extremely well done to sound right. If you miss a little bit the calculations, for example, corner frequencies can end up smearing a little bit quality. I think the PLL route is, let's say, more pure approach. And the way we are doing it as a digital PLL, it's almost perfect, of course, done right.
Putting to one side which is harder to implement, you believe the PLL sounds better.
Yes, I believe that the digital PLL sounds better and is harder to implement.
On your website, you talk about proprietary hardware. What elements of the hardware are you making yourself?
We are using programmable logic circuitry, FPGAs. We like to build all the subsystems inside the FPGA. By using code, you can program the chip to do what you want it to do at the level of performance that you need, instead of using off-the-shelf chips and fiddling around them. This way, again, is much difficult, but the results are much better.
On the website, you talk about how digital signals physically travel as high-speed analog signals on printed circuit boards and connectors and cables, and that you've perfected radio frequency techniques to mitigate these issues. What radio frequency techniques are you referring to there?
Especially related to the PCB design and PCB layout, you need to have control, very good control on the impedance of the traces and the crosstalk between them and the shielding. Yeah, you have to consider that the signals are actually in reality not some abstract ones and zeros, but you can have spikes that go into the very, very high frequency domain. It's something that we especially noticed when we designed our Delta Sigma DAC.
Why did you choose a solid-state analog output stage rather than a valve output stage?
We believe that solid state preserves a little bit better the original sonics intended. Tube stage, of course, very tempting to use due to the sound, which is a little bit warmer, but we believe that's not 100% the truth. It doesn't mean that preamp or tube power amp, they are not good, but for this part, the analog stage, we still believe that the solid state is the best option.
What are the improvements on the Wavedream Reference Signature above the Wavedream Reference model?
There are differences regarding the DAC modules in the first place. So the quality or the grade of the DAC module is higher on the Signature. The performance of the internal clock is higher and the Signature, and of course, power supply. It's a little bit different. And in the end, it's the analog stage, which is different on the Signature compared to the standard reference.
What is the difference in the DAC module itself between the two models?
the number of switching elements. For example, on the standard model, we use multiple switching encapsulated into the same IC. And in Signature, we have individual switches for each bit, and the bit depth is higher on the Signature. And there are differences regarding the reference voltages used. Also, the PCB is designed with a tighter tolerance and better impedance control.
What is the difference in analog output stage between the new Signature version and the prior Wavedream Reference version?
Basically, it's a different schematics and different parts, and we have chosen them a lot of auditions. They measure pretty much the same, but the sound is a little bit special on the Signature.
Your DACs offer 3 user-selectable filters, the linear filter, the minimum phase filter, and the hybrid filter. What are each of these filters doing differently?
The linear filter, it's having this little pre-ringing before an impulse. The most accurate regarding phase, no matter the frequency, but you have this ringing. The minimum phase is more like an analog filter. You don't have this pre-ringing, but it has a little bit different response regarding frequency. And the hybrid filter, it's a combination between those two that we designed in order to have the best of both worlds. My preferred filter, if you ask me.
I was going to ask you.
All 3 filters are very good, and probably it will be very, very difficult to hear the differences because most of the differences are moved outside of the audio spectrum.
To your ears, how do the filters sound different? How does the linear filter sound versus the minimum phase filter versus the hybrid phase filter in the middle of those two?
It's a matter of taste, and it's really up to the whole system which plays, because maybe on different speakers and amplifiers, the results may be different.
Do you feel one of the filters maximizes a sense of resolution in detail, perhaps, versus other filters?
No, because our filters are designed in such a way that they are very, very high performance, all of them.
So what is it about the sound of the hybrid phase filter that you think is a good combination of the linear and the minimum phase? What are you hearing from the hybrid phase that makes you like that one the best in general?
I think it's more fluid.
Why do you use a digital volume control? Doesn't a digital volume control sometimes result in a reduction in dynamic range or bit resolution or both?
Yeah, it's possible that digital volume control to have some negative impact, but we made our volume control on 32 bits. Considering that most of the music out there is 16 bits, you will not hear any degradation. There are pros and cons. Digital volume control is more like a feature. It's not put there to compete, let's say, with a very high-end preamp. If you use it up to, let's say, no more than minus 20 dB or 30, you will not really hear degradation of the sound.
What do you think is the best method of signal connection between the streamer and the DAC? USB, SPDIF, what do you think is the best way to connect those two components?
These labels are just labels. The devil is in the details. It depends on how it's done. You can have poor implementation of USB, or you can have a good one. The same for SPD, for any other. So I don't favor any type of connection or rule out. Of course, USB and I2S are preferred because they support natively very high sample rates. The SPDIF is limited.
Do different power chords affect the sound of your DACs?
We don't design the DACs for a certain type of power chord. This is a fine tuning that every user has to make. Yeah, probably there are differences, but the main thing, the sound is given by the DAC itself. The cable can, let's say, tweak the sound in a way or another. Mainly the DAC character will remain.
What is the next new product we should expect from Rockna?
We are working on a reference server to partner the reference DAC.
Well, thank you, Nicolae. This has been great to meet you.
Thank you very much.
My pleasure.